So I'm going to describe a little paper airplane model here involving energy projects. This is a minimalist model to show where the law of averages arises. So I've got a wind project and solar project intentionally designed to look identical under average assumptions. So they each produce on average 93 megawatt hours. The price is $10. The revenue is therefore $930 for each. This is on an hourly basis. The cost, operating cost, $850, leaving us with a profit of $80 in each case. But as Daniel mentioned, this doesn't model the variability. Well, variability can be modeled within a SIP library. I've copied that. I go to ChanceCalc. I click on the clipboard. We now see the variables that are in the library. In particular, I'm going to put wind energy and solar energy into these two cells. And now we're basically in a Rick and Morty cartoon with thousands of parallel universes. And notice that depending on the day, this looks like a windy day. We've got a lot of wind energy, not a lot of solar energy. These two are not in lockstep. Now I have to put in the prices. Well, these are in lockstep because we're selling in to the same market. And let's see how many trials we're looking at here. 10,000. So everything I'm doing involves 10,000 simulated trials. And what I'm going to look for now is the average profit. So let's remember, the profit of the average assumption was $80 for both of these really symmetric looking projects. And according to ChanceCalc, these are very different when we take the variability into account. $56 for this one, $131 over here. When we looked at the average inputs, it was 80 and 80. Now, why is this? The price per megawatt goes up and down with the wind and solar energy. So if you have a lot of wind energy, chances are it's cloudy, maybe cold, you don't have a lot of air conditioning use, and the price tends to go down. So these are negatively interrelated. On the other hand, with solar energy, you get more of it when it's sunny and hot and the people are using their air conditioners. So this one goes up this way. Here we're back to the original setup. 56 and 131 are the average profits per hour for these two projects. But what if we could hold on to this energy until the price reaches a floor of, say, $10? So here's the opportunity to store energy somehow. And when we do that, we see that our average jumps from 56 to 113. And so this is a huge economic benefit if we can find some way to store the energy.